Hi everyone, I am Dr.D.Princy, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science. In the last two videos, we have discussed about the types of finite automata, deterministic finite automata and non-deterministic finite automata. In this video, I am going to explain about finite automata with epsilon transition, which allows spontaneous state transition without consuming any input symbol. In general, an epsilon-NFA is a non-deterministic finite automata. It may transition on empty string. Epsilon transition consumes no input symbol, but it change the current state to another state. The formal definition of transition function delta is it takes current state and the input symbol. It may include empty string and move to the next state. Epsilon transition do not expand the class of recognizable languages. It provides programming convenience. It is also easy to compose automata for subpatterns. This is a general comparisons versus Epsilon-NFA, NFA and DFA. DFA transition function takes current state and one input symbol, and it have exactly one state transition, that is deterministic. In NFA, the transition function delta takes current state and input symbol, and it can move to a subset of states simultaneously. Epsilon NFA transition function takes an current state, an input symbol or an empty string, and move to the subset of states. All the three recognize exactly the regular languages. DFA is most efficient to simulate, but Epsilon-NFA is easier to design. The conversion path is from Epsilon-NFA to NFA, then from NFA to DFA, or we can directly convert Epsilon-NFA to DFA. So this is an Epsilon-NFA example to accepting the decimal number. In this example, the input string is a decimal number. The input string must contain an optional plus or minus sign to denote the negative or positive number. Next, a string of digit, and it may be an empty. This represents the whole part, followed by a decimal point. So it separates the floating point and the whole number part. So which represents the input string is a decimal number. After a digit, it may or may not contain a digits. So these are the four parts input string must contain. So based on this input string, we are going to design an Epsilon-NFA to accept the decimal numbers. In the formal notation, capital E represents a 5-tuple set which includes a set of states Q, an input symbol sigma, and the transition function delta. Q0 is a starting state and set of final states. The possible input symbol are dot or decimal point, plus or minus, and the numbers 0 to 9. So this is a transition diagram for accepting the decimal number using the Epsilon-NFA. Q0 is a starting stage. It have an incoming arrow. So from Q0 to Q1, the transition function may take an input symbol plus or minus or an empty string. It moves to the Q1. From Q1, if it reads digits, it goes to Q4. When it reads the digits again and again, the it self-looped will be applied. Q4 remains in the same state. From Q1 and Q4, it reads decimal point, it goes to Q2. In Q2, if it reads digits, self-looped will be applied. Q2 remains in the same state. From Q2, an empty strings over an empty string, it moves to Q3. From Q3 over an empty string, it moves to Q5. So Q5 or Q3 or Q2 are the accepting states. Generally, from Q2, there is no input symbol to move to Q3 and Q5. So this is an epsilon transition example for accepting decimal numbers. Thank you.